Awesome. Hello, everyone. Because we do have a packed agenda today, I'm going to go ahead and kick things off. Welcome to our NSIN Vector Pitch Day event. Super excited to have you all here today. My name is Jillian Winstanley. I'm a government program manager on the Decode side and the PM for the Vector program. Our teams have been working incredibly hard over the last 10 weeks on their business plans and marketing materials, and of course, their pitch leading up to today. So before we dive into the agenda and the run of show, I'm going to turn it over to Andrew, the PM from the NSIN side, to provide us with some opening remarks. So Andrew, over to you.
Thanks, Jillian. Hello, everyone. Thank you for joining us today. This is the first NSIN Vector Pitch Day of 2022. We're very excited to have you here today to see these 9 amazing teams. Very briefly, I'll talk about what NSIN is and what we're doing here today, and what the goal of Vector is, and what these 9 teams hope to get out of this experience. So it's a few things, but I'll keep it short. First, what is NSIN? If this is your first time encountering NSIN, it's pronounced NSIN. It's NSIN, but it stands for the National Security Innovation Network. We're a program office under the Department of Defense, specifically under USD R&E. And our mission is to build a network of problem solvers to solve national security problems. We do this in a variety of ways, primarily through our programs. We have 3 portfolios and a lot of different programs. You probably know the exact number. Some of them you may have heard of before. Hacking for Defense, Hacks Hackathon. And when I say hacking, I'm not talking about computer hacking, but hacking together a solution with the available time and resources. We also have our X-Force Fellows program, Experts program, different events such as Starts, Propel, and Foundry. So a number of different programs, all really focused on taking a DoD problem and finding a solution either through students, PhDs, subject matter experts, new ventures, old ventures, anyone we can in our network to solve these problems. And so a lot of our problem solving programs end up with a solution, but a solution doesn't really help anybody unless you get it into the hands of the end user. And that's where Vector comes in. Vector was designed to take alumni teams from our other problem solving programs. And for those teams that thought they had a solution that they wanted to scale into a dual use venture, we would help give them the tools to do that. All 9 of the teams that are here today are about a year old, and they don't yet have DoD contracts, except of course, if you're counting SBIRs or STTRs. So this 10-week accelerator that they're in their last week right now, this is the final event, was designed to give them the fundamental baseline to be able to do business with the DoD. In this program, they learned various things, business fundamentals to start, but also specifically related to the DoD, how to register in SAM, how to write a 2-pager, how to do a white paper, how to market to federal, how to do capture management, how to do fundraising, how to do market research specifically with DoD customers in mind. And of course, through the awesome curriculum provided by Decode, they also had access to both the NSIN network and the Decode network, having multiple workshops and multiple opportunities to give their pitch and receive feedback. One of the things I keep mentioning is the word dual use, and I'll take a minute to explain that. So a dual use venture is a venture that can sell both to the commercial market and the federal DoD market. There are exceptions to the rule, but we've found that, like it or not, because the DoD market moves so slow and requires so much commitment, time, and money, that in order for these ventures to stay afloat past what is a very real valley of death, they need commercial revenue. A few of these teams already have that commercial revenue. And so today, they're going to pitch 9 teams, and 1 team is going to walk away with $25,000. The other 8 teams, unfortunately, are not. But all of the teams, we hope, walk away with the knowledge and relationships they built in this program, and we'll continue to engage with them in the future to help them, regardless of whether or not they're a winner here today. Because we source the teams from this program from a variety of different NSIN programs, X-Force, HACS, Hacking for Defense, Foundry, a lot of the technology areas today are very diverse. Today, you're going to hear anything from medical technology to computer vision, 3D printing, energy technologies, cybersecurity technologies, and then command and control software solutions. So it should be a very exciting day. You're not going to hear the same pitch for the same problem over and over again. Each pitch is unique. Each problem is different. Each market is different. So what we're really focusing on is the strength of the pitch specific to the team. And our 5 judges here today are here to score and help us as much as we can objectively rank these teams. At the end of this day, after all 9 teams have pitched, there'll be about 15 minutes where the judges will meet with each other, but then we will be able to announce the winner at the end of this event, and you will know the top team. So with that, congratulations and good luck to the teams that are here today. Thank you all for joining. If you see something of value in this pitch, don't hesitate to reach out. I haven't seen these specific pitches, but I'm sure there's contact information in their pitch deck. And if you don't see contact information, find me on LinkedIn, and I'm happy to make any introductions. So with that, let's get started. Jillian, I'll turn it back over to you.
Great, thank you, Andrew. Let's get right into things. It wouldn't be a Decode presentation without a quick GIF at the top here. And kind of as Andrew mentioned, the purpose of the Vector program is a 10-week accelerator that takes teams from upstream NSIN programs with the goal of turning them into viable dual-use ventures. And today, our Vector team's hard work culminates in one final pitch day competition. Today, each company will pitch for 5 minutes using their federally facing pitch deck. And following their pitch, our distinguished panel of judges who we have here today and who we will introduce momentarily, they will have 5 minutes of Q&A at the end of the pitch to ask any questions of the team. Then we'll transition into a brief 3-minute break period where the judges will fill out their scorecards before moving on to the next team. And at the end of the final pitch, as Andrew mentioned, we'll move our judges into a private breakout room where they will go over their scores, discuss their scores, and ultimately decide on a winner, which we will announce here live today at the end of the Zoom. And as Andrew mentioned as well, the winning team will receive one $25,000 contract courtesy of NSIN. So before we have the judges introduce themselves and get into our pitches for the day, just wanted to provide some brief rules of the road. The first is please be sure you're on mute the whole time unless you're the one speaking. Second, we'd love to see all of your faces on camera if possible and if your environment allows you to do so today. And then third, today ultimately is a celebration of all of our Vector teams and their hard work over the last 10 weeks. So please feel free to share the love either via Zoom emoji reactions or in the chat. So with that, I'll stop sharing my screen and turn it over to our judges to introduce themselves, starting with Chip Walter.
Hey, hi, Chip Walter. I'm the Director for Ventures and Partnerships at Northrop Grumman. Previous to this, I was about 8 years at CIA where I ran the legislative affairs. And then the last 6 I did with the Innovation Center. So I ran the Innovation Center. Before that, I was in the Navy. All for me. And oh, by the way, say hello to Rebecca.
Will do, Chip. Thank you. Super excited to have you here today.
Thanks. Good to be here.
Awesome. I'll turn it over to Randy next.
Hey, good afternoon. My name is Randy Jennings. Today I'm representing the 75th Innovation Command, which is a reserve component. We do things like this. We look for interesting tech that the Army can use. I'm a major in the 75th. Secret Service 20 years, work for NASA now in the digital forensics world. So glad to be here. Thank you.
Excited to have you here, Randy. Thank you. Lisa, over to you.
Hello, Lisa Sanders. I'm really blessed to be the Director of Science and Technology at U.S. Special Operations Command. And we provide all of the capability development that supports the breadth of special operations, and really looking forward to the opportunity to see what you all have to show us. Over.
Fantastic. And last but not least, we have Assad.
Hey everyone, great to be here. I've I think done a few of these, and so these are really fun experiences. Assad Akram, I'm an innovation officer with the 75th Innovation Command. Ms. Jennings and I used to be on the same team, so good to see her, sir. I traditionally scout for startups in the energy, materials, and cyber portfolios, but I've always enjoyed kind of working through these and giving folks our perspective as we've learned it, not just in Army ventures, but in DoD ventures. So excited to be here and hope I can provide some value to y'all.
Thank you, and super excited to have you back. Okay, great. So with that, we will get right into our pitches. Teams, again, you'll have 5 minutes, and Emily will be holding up 2 minute remaining, 1 minute remaining, 30-second remaining, and a time warning. So please keep an eye on her screen. We do have a tight agenda today, and we'll have to unfortunately cut you off right at the 5 minute mark. And one final reminder to anyone who trickled in a little bit late, please, if you're able to rename yourself, just so we know all of the organizations folks are coming from, that'll be super helpful for us as we go through the day today. So with that, unless there are any questions, I will turn it over to Ian from Kupros, who will be our first presenting team. Awesome, whenever you're ready, Ian.
Excellent. Thank you so much, everybody, for being here and listening to me speak, and all the rest of our teammates here. I wish them all the best and moving forward. Thank you. Hi, I'm Ian Ramsdell, and I'm the CEO of Kupros. Kupros aims to revolutionize the 3D printed antenna electronic market with an all-metal copper filament that offers a more cost-effective, versatile, and efficient printing process than any other existing solution. I'm really excited to announce that we've been approved for a Department of Defense grant that'll be covering the cost for all our capital equipment and enough raw materials for 25 prototypes. We're finishing up this awesome Vector program, and we just got accepted into the PenFed VEIP Master's Program, which will help us with fundraising for and moving into our growth stage. There are currently 2 options for 3D printing electronics and antennas. First are expensive 3D printers that cost between $100,000 and $500,000 that can only be used with that company's filament. This filament doesn't work with any other 3D printers. While this option prints highly conductive materials, because of the high price tag, utilizing this tech is out of question for innovators. These specialty printers also waste time and materials as they need heavy post-processing. For example, most copper designs printed with these printers need to be baked for 8 to 10 hours to cook off additional polymers from the final product, and this often leads to warpage and shrinkage. The alternate solution is to use existing filaments with standard printers. These existing filaments can be used with affordable common printers, but are only conducted enough to power simple LED lights. All these problems apply to 3D printed antennas, where some companies are having to rely on inefficient alternatives such as copper tape. The existing solutions do not promote innovation, but rather stagnation. We aim to disrupt the 3D printing electronics and antenna market by eliminating the need for expensive specialty printers, post-processing, and inferior filaments. Future iterations of our formula will hold even more potential for applications in the aerospace and medical device industries. Kupros Inc.'s all-metal copper filament, or Cu29, is made without any polymer additives. The filament is used similarly to consumable ink for home or office printers and can print anything that requires conductive properties, especially antennas requiring complex geometric shapes such as fractal and 5G antennas. Our unique formula, Cu29, results in a filament that can be used with the most common 3D printer available, the FFF style. Because of the characteristics of our formula, we don't have to worry about post-processing. This enables rapid prototyping by any user. Our filament will be the most conductive filament on the market at over 8,000%. Yes, you heard that correct. 8,000% more conductive than our closest FFF competitor, which means that our filament can power an entire prototype circuit board instead of only a couple LED lights. Finally, the filament does not separate from the base material when electricity is passed through it, which means we have the potential for use in integrated circuits and sensors. We'll charge customers $2,500 for a single kilogram roll of filament, with increasing price points as iterative formulas are developed. Within 6 months of our initial product offering, we plan on releasing our second formula, which will be 10 to 15% more conductive. We are also exploring licensing with the right partners. We've had customer discovery calls with well over 100 potential clients with promising results. such as a conversation with the lead electrical engineer at NASA's Goddard Space Flight Center, who projects 50 to 60 units of samples initially with potential partnership opportunities to follow. The Army Research Lab estimates a purchase of 6,000 units annually. Optisys is currently 3D printing antennas, and they said demand is so great, there aren't enough printers in the world to meet that demand. More importantly, we've had samples requested by the US Navy Research Lab, Sensana, GE Healthcare Coils, and Blue Origin. We have the funds and the space to start manufacturing our first 25 units that will begin by Q3 2022, and our first mechanical engineer joined our team. My partner and inventor, Harrison, and I bring experience from extensive military careers and emerging deep technologies from a cutting-edge national laboratory. Kuprosh's tech is at a crossroads of our versatile experience in electrical, metallurgy, entrepreneurship, research and design, 3D printing, and additive manufacturing. Harrison was awarded the Office of Naval Research Design Innovation Award for the CU-29 filament. We are currently seeking partnerships and potential customers with relevant stakeholders in the government in additive manufacturing 3D printing. The current solutions will cost you up to $500,000, extend your manufacturing time by up to 10 hours for each part, and waste materials. Our new to market filament reduces waste through our all metal formula, cuts production time in half, and reduce cost of compatibility with the most affordable printer on the market to remove expensive barriers for innovators. Thank you for your time, and I'm happy to answer any questions.
Great.
So this is Chip. I have a question for you.
Yes, Chip.
So on these antennas you're printing, can you print around the copper with another another polymer, another plastic to conceal what you're printing?
Yes, Chip. So that's one of the exciting parts about that from the R&D process from the laboratory was the engineer and the inventor was able to produce enough filament, print it out of a printer onto an underlying plastic material. I believe it was a PLA. Then he was able to thermocycle it to the point of failure where it just melted into a small pool of metal. And there was no delamination from the underlying materials, which just leads us to believe that we're going to be able to print integrated circuits exactly like you said, Chip, where we'll be able to print a housing unit, say for the top housing of a drone. And in that top housing unit will also be printed certain sensors that we can print with our material, as well as an antenna. And this is where we kind of chose the direction for our initial penetration into the antenna market.
Thank you. That would be really, I think, disruptive. So
thank you, Chip. Yes, that's exactly what we believe as well. The current people trying to do this, their filament is not very conductive. So the only thing that I've seen them power was a couple LED lights. I'm sure there's more in R&D labs and other companies, but on the public market, there's nothing available currently.
Great, thanks.
All right, this is Lisa Sanders. My question is about, you talked about the supply chain issues for the competitors and their weaknesses and strengths. Can you talk to me about how you're actually going to be able to handle the manufacturing for this? You mentioned your grant and the capital equipment, but where's your supply chain issues, and how do you think in the economy right now with supply chain issues, you'll be able to maintain delivery? Over.
That's an awesome question, and actually quite relevant, especially with today's current market economy going on. There's a lot of supply chains disruptions. There's a lot of issues with sourcing materials from overseas or even from certain allies we have. One of the best parts about this product was when I jumped into a market analysis, the first thing I discovered was that the United States is the 5th largest miner of copper in the nation. That being said, we've also discovered that not only are we going to be able to secure our supply lines from this area, but we'll also be able to utilize possible green recycling technologies as a source, an alternate source, if not our main source, coming from electrical recyclers here within the United States. We're really interested in doing that because the chemical process they use results in a finely grained material, which is exactly what we need for our production. The other underlying materials, those are still the trade secrets. Same thing applies. There's plenty of sources within the United States, and we don't anticipate any supply chain issues. The one supply chain issue we saw was one machine that we need for our manufacturing process. We have to order from the UK, but they've assured us that there isn't any problems with them getting any of their equipment to the United States currently, and they don't foresee any problems in the near future. But we do have alternate pieces of equipment if something like that does arise, and we can't actually build our manufacturing process on the initial equipment we estimated.
Awesome. I think we have time for about one more question, if any of the judges have any last thoughts. Great. Okay, then judges, it's over to you. We'll have a few minutes for you to populate your scorecard, which Andrew from NSIN sent to you via email. If you have any issues accessing the scorecard, Andrew will be able to send you the link. So feel free to let us know. And in the meantime, Ian, you can go ahead and stop your share, and I'll toss it over to my colleague, Terry, who will be providing some between pitch entertainment for the audience. So judges—
Thank you very much, Jillian.
You're welcome.
Thank you, everybody.
Yeah, great job. So judges, feel free, you can go heads down, fill out your scorecard, and then Terry, over to you.
Hey everyone, and great job, Ian. Can everyone see my screen with the space background here?
We can see it, Terry.
Perfect. All right, so while our awesome judges are filling out their scorecards, we're gonna have a little fun for everyone else in the audience. We are going to do a game we like to call Geo Trivia. And so the rules of Geo Trivia is you will be shown a bunch of different photos from different famous locations around the world from a Google Maps perspective. So from a space perspective, everything will be, we try to orient everything north. So everyone's going to be given 30 seconds to 1 minute to try to figure out and guess the location. And while we wish that we could give out 25K for every correct answer, today the prize is really just our love and admiration. So everyone zone in, start thinking strategically about where in the world this could be. And our first one should be a little bit of an easier one to guide you into it. So go ahead and take the next 30 seconds. If you think you know, shout it out or put it in the chat.
Kyle was fast. Kyle says Giza, Terry, is that right?
What was it again?
Kyle says Giza, the pyramids of Giza.
Nice, good job. All right, we start off easy. These will get a little progressively harder as we go through it. So nice job. Next up. Jillian, I have trouble seeing the chat, so if anyone throws it out there, let me know.
Okay, we have someone guessing the Vatican. Is that Elmer making a guest appearance, by the way, in the background?
That is not Elmer making an appearance in the background. Someone else's dog is warning them about a squirrel. But any other guesses?
No worries, Chip. Thank you.
No worries. All right, final guesses.
We have 3 guesses for the Vatican in the chat.
Also, I will say Ryan did have it first. He just accidentally direct messaged me. So if it's correct, he was the first one. Just as a heads up.
Got it. Oh, a bunch of smarty pants over here.
Wow.
All right. Let's see if you guys can get this next one. Maybe a little harder. Any guesses?
One guess for the World Trade Center.
All right.
Centers, plural.
All right, I'm gonna give it a couple more seconds here. Others will wrap their brains around it. All right, final call. Whoever said World Trade Center, you have a future at NGA.
Kyle, I think it's 3 for 3. So I think we move on to the next team, and hopefully the others get their juices flowing a little bit.
Awesome. All right. Sounds good, team.
Fantastic. All right, judges, we are going to move on to the next team, and that is Opto Relay. So Opto Relay team, whenever you're ready, feel free to bring up your slides and we'll get right into it.
Oh, great. Thank you, Jillian. Hi, everyone. My name is Dominic Doctor. I'm from Opto Relay, where we're the microgrid optical power augmentation solution team. And so I'd like you to envision the following. Power systems require constant logistical support. And so with the current ongoing conflict in Ukraine, you have these vast convoys stretching up to 40 kilometers long, and they're stalling and they're sitting in place due to unforeseen circumstances, and they're running out of fuel. And so at that point, you become an easy target. So what do you do in this situation if it happens to us? How do we ensure operational resiliency? There are solutions. However, Current microgrid designs suffer from a variety of reliability issues. And so we have portable gensets, which generate quite a bit of power, but they require frequent maintenance, suffer from high breakdown rates, fuel supply lines can be ambushed, and they have all these different signatures from heat and sound that could reveal your position. Renewable energy solutions are great as well. However, they're unreliable due to intermittence effects. So if the sun goes away, you get no power, and they have a large footprint, which can become an easy target. Fuel cells, they're high in material costs, they're very sensitive, and if they're mishandled, they can prove to be highly explosive.
Hi, so our solution is DION. So we want to deliver power at the right time, at the right place. So we're creating a wireless power transfer technology to deliver several kilowatts of power over kilometer distances. So this is enabled by Dominic Doctor's patent pending modeling software, and it'll have a relaying transceiver, which we want to have easily integrated into current ground and airborne platforms. DION as a power source is multi-purpose, and so it can be used to power anything that the transceiver can be attached to.
Great, and so let's dive in a little bit into how this exactly works. So it all starts with real-time modeling and simulation of how your laser beam propagates through certain atmospheric conditions. So it accepts any laser specifications, so it's very adaptive. It's able to account for specific efficiency losses based off of weather conditions, aerosol concentrations, and other variety of atmospheric conditions. And then it takes a specific cross-section within the beam path, averages the power density, and converts it into a power conversion efficiency from a photovoltaic cell. That information then gets fed into this adaptable distributed network called DION, which is comprised of all these different ground and airborne nodes on the battlefield or in whichever domain that you would like to envision. And it routes the specific route that's the most optimal and most efficient to get power to a specific node in need.
So we've identified several potential use cases for the DoD, specifically expeditionary forces and unmanned platforms. Expeditionary forces are often difficult to reach and support, leaving them vulnerable to being stranded. DION would be able to support them even when we can't physically get to them. Unmanned vehicles, they're power intensive, with a significant portion of their load being their energy storage. Attaching a DION transceiver would increase their strategic value by increasing their runtime or their loadout.
All right, thanks. And so I'll talk a little bit about our team. So I'm Dominic Doctor, I'm the CEO. I'm a PhD in applied physics at Texas A&M University. And so this work came about from the NSIN X-Force program, where we were working with Dr. Corey Bergsworth, who's our mentor and advisor and our DoD point of contact. And along with me, my co-founder is Daniel Kenner, the Chief Technology Officer. And so he recently graduated with a bachelor degree in computer engineering from SDSU. And so I'll be working on the physics-based modeling and simulation, as well as laser power beaming converter. So the entire laser source to photovoltaic cell, the end-to-end. And then Daniel will be working on the guidance and tracking control system, as well as the software UI. We're currently negotiating in Credo with Naval Surface Warfare Center at Crane. And we're also invited to join NVIDIA's Inception program, where we can see the potential of using AI to further optimize this mesh distributed network. Thank you. And if you have any questions, please let us know. Otherwise, here's our contact information.
Lisa, go right ahead.
Okay, so this is Lisa. My question for you is I want to make sure basic understanding and then another question.
Sure.
So you're just doing the modeling for distributing the power. You're assuming somebody's actually providing the power on the front end that you're distributing. Is that true?
So we're actually both a software and hardware company. So what we've done, we've conducted experiments at Texas A&M that show proof of principle. So we have a laser source having the beam propagate over 2 meters in distance onto a photovoltaic cell, and we were able to measure a power curve on that photovoltaic cell. And we proved to show a 36% efficiency at that point. And there are of course rooms for improvement. That was just a basic underlying experiment.
So you generate the power that's in the laser, or you've been given that power source and you're optimizing the delivery?
No, yeah, this would tie into existing power sources, whatever you have in the field, ideally with some static installation that, is more easily supported.
Okay, excellent. And then what kind of a signature do you think that you mentioned the high signature of the generators? What kind of a signature do you think that your system would have? What would be the threat vector if we were to utilize that in a battlefield area? Over.
And no, thank you. That's a good question. And so it depends on the different wavelength that you use of your laser. And especially when you're working with high energy laser sources, there are certain imaging capabilities that would be able to see, for example, a laser path in the air. But if you're working within specific operations that require more stealthy operations, then you can decrease that power and you won't be able to image that beam path directly. The heat signature, we're working on a two-phase cooling solution using microfluidics as well for the photovoltaic cell. So when the laser beam propagates and it's incident on that receiver, you're going to generate some heat. So we're working on a two-phase cooling solution, which would be able to dissipate that heat and reduce the overall signature. Thank you.
Any other questions for the Opto Relay team? We have a couple more minutes here. All right. Sounds like there isn't anything. Thank you, Don. Thank you, Daniel. Good job.
Thank you.
Thank you. Thank you, everyone.
Yeah. And then judges, feel free to go back to your scorecard. And then Terry, over to you again. Take us away.
All right, everyone. Round 2. Can you guys see the screen? Awesome. All right. So you know the drill. 30 seconds to a minute. Let's see you smarty pants figure it out.
We have 1 vote for Machu Picchu in the chat. 2 votes for Machu Picchu.
All right. Final calls for Machu Picchu or anywhere else in the world? Ryan and Enan, a little too smart for your own good. Machu Picchu. All right. We'll see if we can stump any of you guys. Next up. Where in the world are you looking at?
I'm not sure if you can see. Oh, Ian just said Disney, Terry. Yeah, same with Sarah.
All right. Final calls. Disney World in my own Florida. You can see the little Mickey Mouse.
I was gonna say the same thing, Ian, how big the parking lot is compared to the rest of the photo.
Yeah, it's huge. Yeah. I was gonna give people grief. It was like, man, all the parents should know this, but people figured it out a little too quickly. Awesome.
All right, maybe one more, Terry.
Yeah, one final one here. Give everyone 30 seconds for this last one.
Ian says the NSA.
All right, that's a guess. Anyone else? Final calls in the last 10 seconds here. All right, 3, 2, 1. Close, Ian, but no cigar.
The other IC.
Yeah, but your head was in the right space.
Love it. Awesome. Good work, everyone. We're starting to stump you here. So there's just a few more opportunities later in the day. Great. Okay, next we have our next presenting team is Jamie from Traverse Operations Solutions. So Jamie, whenever you're ready, you may take it away.
Okay.
Oops, you're back on mute, Jamie, I think.
All right.
There you go.
On the 23rd of February, 2022, days before the Russian military invaded Ukraine, a mysterious cyber attack targeting the defense, the Ministry of Defense, wiped all of the software clean. And then just a couple of days ago, 5,800 turbines across Europe were attacked by cyber hackers. So America's ability, or America's adversaries' ability to disrupt and deny access to systems is knocking at our doors. 2021 was just a peek behind the immense chaos that could occur if our critical infrastructure was attacked. So think about JBLM meats or the Colonial Pipeline. If you're unaware, 2 separate water facilities were targeted. This allowed for a new level of hybrid warfare to penetrate our national security. My name is Jamie Aguirre, and I'm the CEO and founder of Traverse Operations Solutions, LLC. I am a service-disabled woman-owned small business developing a hardware and a software product named Sentinel to help the Department of Defense and the commercial sectors cyber protect their legacy platforms. So the problem is that the Department of Defense will not survive a simultaneous cyber attack on its mission critical systems. Why? Because there's legacy protocols, there are no backups, there are no encryption. Operational technology and informational technology, the integration has amplified the vulnerabilities, making it inherently insecure. So we have a dual purposed technology, but our focus right now is the Department of Defense and cyber protecting our legacy platforms. So here's our solution. Sentinel is universal, it's scalable, it's an embedded customized couplers with micro devices inserted in between each remote terminal and bus wiring harness. It's a bidirectional cybersecurity protection for legacy platforms. So here are our milestones. So we were, I was accepted into the NSIN sponsored FedTech DIA of 2020, June of 2020. And I just finalized the licensing agreement with AFRL in December of 2021. So it took just shy of a year. 2022, we started out real strong. We have applied for the NSIN Maker and our application has been submitted. We're pending approval. We were accepted into the NSIN, our Vector cohort that we're here. We applied for the Department of Navy SBIR, and we're looking to go into research and development. And then 2023, hopefully experimentation will be completed. We'll have identified a program of record and then move into commercialization. This is our competitive market. Really, our number one competitor is Shift5. I just recently learned that they're building out a very, very similar capability. But what really makes us different is my team is composed of retired special operations soldiers. So we understand the importance of having equipment that is not just reliable, but allows for us to do and conduct a mission without worrying about whether or not our equipment is going to fail. So competitive pricing, right now I'm a lean startup, so I have no overhead. We don't owe anybody anything, and we haven't really looked at any larger investors to pick up the cost. So we're looking pretty good here. So this is my team. Once again, we're a bunch of retired special operations. We do have an exploitation analyst that just recently came on to the team. I'm very happy to have him. But we're definitely looking forward to getting our mechanical engineer to get our prototype to MVP. So pending your questions, this concludes my, my pitch. So thanks.
Awesome. Thank you, Jamie. Judges, over to you if there's any questions.
Yeah, I've got a quick question just on the market opportunity here. I mean, operational technology just in the commercial sector seems like a pretty wide space to go target. So are there specific subsectors that you would want to kind of target first in your acquisition? And what does that look like? What are the scales of the opportunity there in the commercial space that you guys are seeing?
Yeah, so it is definitely it's so big that trying to kind of narrow it down has been a little bit challenging for me, only because we know that the cybersecurity span is about like $50 billion. I mean, companies are looking to cyber protect, whether it be SCADA or, you know, going to individual, whether it be trains, vehicles. So it is pretty big right now in the commercial space, but we've really just focused in on Department of Defense and narrowing it down to the Department of Navy right now, in hopes that we get, you know, brought into this cyber for, it's a cyber hunting tool. And so we would be a part of that larger project.
Got it.
So, I mean, yeah, because these data buses are on like weapon systems. They're on space. I mean, you just name it. They're basically everywhere. Yeah.
That makes sense. Thank you.
Two questions with regard to that. So you're talking about this being a physical device. One question is, where's that going to be manufactured, and how are you going to be able to scale that manufacturing given the volume you're talking about? And the second question is, because it is a physical device, and a lot of the commercial, you know, IT infrastructure is done wirelessly, do you see an application? Is that why you're starting with DoD rather than commercial? Over.
Yeah, so with it being a customized device, I will tell you that's definitely been challenging, just because in my open research, a lot of these 1553 buses and a lot of the couplers that are actually being manufactured in Beijing will be focusing to build these out here in the US. And I was lucky enough to find some 3D modelers who do have that printing capability that would be able to do customized couplers. But really, it's definitely a lot of our products are being built in Beijing. So that's also something that we have to, you know, because that is something that we've been definitely looking at really closely. And I think for the commercial sector, really, to be honest, my heart and my passion is with the warfighter. I just retired out of the Special Operations Command. And so moving into the commercial space has just not been what we were looking at, especially when I learned the vulnerabilities that our legacy platforms are currently existing within them. So that was really my reasoning behind sticking in the defense space. So,
you know, having that supply chain, having that supply chain come from overseas like that, you know, I'm concerned about your IP and all the other stuff that you're trying to protect, as much as you are trying to get that your supplies. So.
Yeah,
that's something you're gonna have to work through really quickly, because a lot in DoD and the IC are gonna go.
Well, yeah, that's what's really interesting about Shift 5, right? You know, at first I was like, our what separates us is OPSEC, right? We live in the world of OPSEC. But if you like look at their, you know, websites and everything that they have, you know, pushed out on the internet. No, we absolutely look at the intellectual property and what we have, as it's very, very, very sensitive, right? Even in discovery calls, I've done about 80 of them. It's not very, it's not a piece of technology that people are openly saying, hey, we have all these vulnerabilities within the space. But so yeah, no, we all hold pretty high security clearances on our team. And but it's definitely finding our way into into where we can actually have more of a deep dive into the technologies. And so that's why we're hoping, you know, to get in with the Department of Navy. But yeah, so.
Okay, thank you, Jamie.
Yep. Yeah.
Awesome. Thank you, Jamie. Thank you, judges, for the questions. We will move into our transition period now. So feel free, judges, to fill out your scorecard, take a few moments to do so, and then we're back at it with trivia. Trivia with Terry.
All right. Can everyone see my screen?
Yes.
Awesome. All right, everyone, you know the drill. You got 30 seconds to figure out where this is in the world. All right. Oh, did I finally stump people?
I know, I'm not sure if you can see the chat now, Terry, but it's looking like no guesses on this one.
Uh-oh. Finally defeated the crowd. The Alhambra.
Hold on, Alhambra. I was gonna say it. You beat me to it.
First of all,
doing
Chip,
the grading.
First of all, Chip, you're supposed to be grading.
I just submitted it. I can't type twice. It's Alhambra. It's in Grenada.
We'll give it to you. We'll give it to you. That's okay.
You're killing me.
Chip, I'll give you bonus points for multitasking there.
Yeah, exactly.
I was trying.
Very impressive. All right. What do we have next here, people? Feel free to call it out if you think you know it.
I'm going with Versailles.
Chip with Versailles, doubling down on the insights. Anyone else?
Lisa guessed the National Mall in DC.
I'm saying Versailles as well. I just don't know how to spell it.
No worries. All right. Very impressive. The National Mall. Come on, Lisa. You're better than that.
No, I'm not. I could have gotten the Disney one, but I was getting caught up in my response to the other thing because I spent a lot of time at Disney.
You know, it's okay. You're doing the right thing here. You're being responsible instead of goofing around with the rest of us. Jillian, do we have time for one or two more?
Yeah, let's do one more.
All right, perfect. Let's see what you guys got.
Mount Everest. Mount Everest.
All right, Everest. Chip just crushing it. Nice job.
That was a tricky one. We had a few other guesses too in the chat. But Everest it was. Everest was the winner. Cool. Okay. On to our next team. Thank you, Terry, again for helping us out in the breaks here. We are going to move on to Team Neupro. So Matt and team, feel free to take it away whenever you're ready.
All right. So, good to go. Well, we are LOPA, Lab on Patch, Traumatic Brain Injury Diagnoses via a real-time, non-invasive blood analysis wearable. So we're here to solve limitations in traumatic brain injury diagnosis, specifically being that to do TBI diagnosis, you need to get to the blood, and getting to the blood and doing a blood draw is hard to do outside of a clinical setting. So imagine you're on a medical evacuation on a helicopter with suspected TBI. Well, you will not be drawing the blood, first because of the environment. The vibrations make it impossible to do a blood draw. And second, because you may not have access to the trained personnel or the equipment or testing equipment needed to do the diagnostics. Now, this is a big deal because lack of or delays in testing negatively impact patient outcomes. So our solution is a wearable patch with embedded subdermal sensors which read out real-time to off-the-shelf camera technology. So what does that look like in practice? Well, it's an integration of diagnostic technologies developed by the Naval Research Laboratory. And what that looks like is a combination of an advanced optical biosensor that is trained on the TBI biomarker, subdermally implanted via microneedles, which then reads out to a mobile device running local software, which does not need internet connectivity. And developing this to market is 2 stages. The first is the prototype for the subdermal biosensor for the TBI analysis, which has the design and testing ongoing as of December 2021. Following up on that is the hardware and software configuration, which, when we combine these 2, brings us to the LOPA patch. Now, for customer discovery, we reached out to private and public stakeholders. We're connecting with DoD traumatic brain injury programs to understand the current practices for how TBI is diagnosed in practice and how our technology would add value to those procedures. Interviews also led to other conditions that have biomarkers, such as congestive heart failures, where we could apply this technology, as well as other situations, such as high school or professional sports, which have exposure to TBIs. For market size, the point of care blood testing is huge. It encompasses everything from glucose monitoring to TBI diagnostics. There are incumbents, such as, well, there are incumbents, but they're limited by the fact that they still need to get to the blood and they still require specialized equipment, where we are essentially a self-diagnostic tool which does not require expertise. And we're the right team to build this. We have the relationship and the CRADA set up with the inventors at the Naval Research Laboratory. We have experience separately raising SBIRs as well as private fundraising. And we have the technical and business expertise needed to guide the development and launch the product. Now, for progress and next steps, we're continuing our CRADA with the NRL. We will be filing the intellectual property jointly with the NRL, and post filing of the IP, we will be pursuing other SBIR and startup funding opportunities. Which brings me to the ask, which is your support for the $25,000 for material procurement. Right now, we are designing and developing the subdermal sensor prototype, which is funded by the NSIN Maker program. But with this $25,000 award, we will have the funding needed to procure the materials needed for the evaluation and testing of the subdermal sensor prototype for TBI detection. Now, we have the labor lined up with the NRL secured, but this $25,000 funding is critical to get us the materials we need to keep the development moving. So that is the presentation, and I'm open for questions, or we're open for questions.
This is Chip. I got 2 questions for you. The first one is there a need to determine TBI in the field? Or can you wait until you get back to is this to try to get them off the battlefield so they know something's wrong?
Well, there's 2. One is there's a limited window for these biomarkers when they're present in the blood, for solidly identifying whether or not a biomarker for TBI is detectable. And following that is there's different treatment protocols if biomarkers are present versus not, and that will indicate what kind of care they need, which is why it needs to be moved more out to the field versus wait and see for later. And I have my teammates, Tuan and Sandesh, on the line as well, and they may jump in as needed.
Okay. And maybe I missed it. Where is this subdermal sensor placed?
Under the skin.
Where?
We're thinking, yeah. We're thinking arm.
Yeah, we're thinking, right, so this is Tuan. Yeah, we're thinking it right now is on the arm. Matt already mentioned that the timing is really important for TBI. There's you're missing a window, and it's really important. It is an indication for TBI. You're going to do imaging right away. So this tool allow you to do a very efficient attach to the arms and and quickly detect whether you have a signal for TPI or not.
Okay, thanks.
And this is Randy. So this is something that is going to be basically installed in the person, or is this a patch that goes on? How long will this last on a person?
So typically we are thinking about like 2 weeks, depends on the integrity of the patch itself and the optical sensor. So those are the metrics that we would need to be testing in our next phase of evaluation.
Thank you.
Which leads into my question. Again, you guys are probably going to think I'm a broken record. So who's going to make this thing for you? And have you been in contact with them? Over.
So we haven't reached to the point where this is we'll be sourcing out manufacturers for this because this is a very specialized biomarker. The current CRADA allows us to optimize and evaluate the TBI biomarkers using this prototype. But that would be something that we would be considering as soon as the prototype is almost ready and good for testing.
But even speaking, I'm going to chime in here as well. Speaking to the concerns is, regarding the intellectual property for this would be not something that we could open up to, outsource to elsewhere, right? This would either be through us or with a partnership with somebody else domestically. Because we don't want leakage of the IP as well.
Awesome. We probably have time for one more quick question if there's a last question from the group.
Real quick on the subdermal patch again. Obviously, you just started testing it. Considering this is going to be, the people that are wearing it are going to be sweaty, they may be in dirt. What are the chances of this thing getting infected and causing trouble like that?
So that's a great question. Right now, we want to make sure that the signal noise ratio is higher with those optical sensors to be able to pull data with any kind of like sweat or dirt or any of that background. But the second part of your question related to infection, there have been tattoo-based modeling systems that have shown good promise as well, which minimizes infection. So those are some of the things that we would be looking once the prototype is ready.
Okay.
The delivery mechanism and the minimal invasive procedures would probably reduce any kind of infections, we think. But it needs to be tested out.
Okay, thanks.
Awesome. Thank you, Neupro team. We will shift into our transition period here. Judges, feel free to get going on your scorecards and then back over to Terry for our geotrivia.
All right, let me get this map up here. All right, a random white patch in an arid landscape. What do you people got?
Area 51.
Who said that?
It was Chip, and also Ian was quick on the draw in the chat, saying the same.
I really thought this was going to be harder for you guys. It's a little upsetting, actually. Chip is.
You gave some clues.
Well, right now the runway's right there. Come on.
All right. I'm gonna have to revamp this whole deck.
And clearly, you don't see the UFO sitting on the ramp there.
Yeah, that was exactly the little green men is what we should have zoomed in on. All right. Next up here.
This might be a stumper, Terry.
All right. I like stumpers.
Ryan's
got to. Yeah.
Vegas. That's a good guess.
That is a good guess. All right. I'll give 5 more seconds.
It looks like the Boeing manufacturing helicopter facility to me. I know they've got across the main street, they got a bridge.
If Boeing has that pool, I definitely need to go work for them.
I was going to say, Lisa, I don't know what factories you've been to, but we should go next time you go, let me know so we can Decode can come with you.
See, this is because I'm not an image person. I'm not an image person. This stuff, I'm just looking at the bridge across the road and thinking that's the Delaware River, which it's a little too clean to be the Delaware River, right?
Oh my God.
Lisa, there's a reason why I outsourced this job to Terry and I'm not doing it myself. So I'm on your side here.
We all have our strengths. This is not mine.
I should have known better. Here's my kid's Burj Khalifa Legos sitting behind me.
Oh my God, that's awesome.
So one more, Terry, maybe?
Let's do it. All right. And Lisa, for just so you know, this is not Lockheed's factory.
I don't see a building here.
Pearl Harbor.
All right. And I see Pearl Harbor in the chat. You guys are just a little too smart, a little too good. Nice job.
Fast. Damn.
Yeah. Yeah.
Yeah, Evan, we have a great crew here. Evan is another one of our decoders who just joined. We have a great crew of geoguessers. So welcome. And we will switch over to our next team, which is Ryan Shaw from Apagos. So Ryan, whenever you're ready, feel free to take it away.
Thank you. Yeah. Can I just start?
Yep.
Okay. Good afternoon, everyone. My name is Ryan Shaw. I'm presenting Hermes, which is a digital recall roster system. So say you've got an emergency situation, such as an active shooter or a jet fuel leaking. You want to let all your personnel know as soon as possible to stay out of the area, give them the necessary information. The current protocol is the personnel recall system. You talk to base leadership, for example, who will have a list of maybe 10 people on a piece of paper or a notes app. And that is their names, their phone numbers, their contact information. They'll talk to their 10 people who talk to their assigned 10 people. And you've initiated what's called a phone tree. The issues with this, however, are say someone gets missed or someone's late, which does happen very easily with say 7,000 people on a base. These people build exponentially, and ultimately that's a large part of the reason why it doesn't generally get done in under protocol time. And when you've got that much manual labor, you're using a lot of labor hours, a lot of things that can be shifted to more mission critical activities. And this is 2022. We can automate this process with Hermes. And if you've ever played the game of telephone, you know when you're relying on 7,000 people's manual labor, certain messages may get diluted or things may fall through the cracks. So Project Hermes is a way of taking recalls and making it for 2022. We can type out a message and send it to everyone, whether that's the entire base or just by internal division. And it goes straight to service members' SMS on their phones, all computed on the DoD compliant cloud. We have a series of real-time updates currently that are being done manually, such as time statistics or acknowledgement, that can all be automated with the process. So why is this something for your organization? It not only allows you to blast out acknowledgements to everyone, it allows you to do it for units as well. Say you just got a specific group or squadron within your overall base. Second, it runs on AWS GovCloud, which meets the necessary DoD compliances in order to be viable in the real world. And finally, there were concerns about advancing the security state, but we are leveraging existing information and we're actually removing it from the hands of the individual. So while today, everyone has all of this information, your home address, your phone number, for example, on a little piece of paper across the base, we're putting this all in the computer. So we're actually increasing security and increasing privacy. So it is protocol across the DoD to conduct recalls, not only in the government sector, we see the military and military adjacent groups, but also for non-government entities. These are all organizations with very strong hierarchies with the necessity to blast out information to a large number of people in a very short amount of time and track acknowledgements. So we have a strong use both in the commercial and in the federal spaces. So coming out of X-Force 2021, we've built a baseline prototype. This is just an example of the UI. We're looking to beef that up. But for example, you would first sign up, then you would sign in. The commanders would have the option to send messages through this platform, and then they would have a logs page, of course, for the commander's eyes only for tracking. So the competitive landscape we see mostly in the made for government. There's a series of internally created systems within the US Army. None are very widespread and standardized. And then from a company perspective, we have Muster, which is application-based versus us who are SMS-based. And they're really trying to do 4 or 5 different things at one time, which makes them spread rather thin, and they're still in the beta phase, versus Hermes, which is trying to do one thing really, really well and that's fulfilled the niche of the digital recall. So I am an X-Force alum 2021, where I started this project along with my advisory panel, Joseph Enger and Brady Flynn, who have countless years of experience in Air Force innovation, who understand the process and really understand the need that the recall system allows for. So the opportunity, the project reached semifinalist status in AFWERX Spark Tank. If you aren't aware, it's the Air Force internal innovation system, which garnered a lot of attention from about 12 Air Force bases saying, let us know when SIBRs are rolling around, or you need to do testing. We're very interested. This is a pain point. Second, not only in the Vector incubator, but in the USC incubator, which is allowing us to work for dual use, as well as we have an MOU signer in Luke Air Force Base, helping us move forward. So what does your vote mean? At the end of the day, we're looking to take that funding and directly hire development team. Even though we have a baseline prototype, we want to build it up, do beta testing, and have an MVP to eventually take it to market in the third quarter of 2023. So thank you everyone for your time and helping us bring military communications into the computer age. The recall is a very strong pain point right now, and Hermes allows you to bring it into the 21st century and automate that process. I'll take any questions at this time. Thank you.
Hey, thanks for that, Ryan. This is really helpful to understand this. What are there kind of two-way communication capabilities, like from a reaction perspective?
Yes.
Something that comes to mind is the Army's AdPass system. It's like the world's biggest disaster in terms of recalling people or checking on people when a disaster happens. So is that factoring in here?
Yes, exactly. So that is our major point of, I would guess, value add. Current systems are mass notification where you blast it out to everyone and that's the end of it. The recall allows you to blast out a message, get it on your SMS, and then you type back, say, whatever it is you put in settings, maybe it's yes, maybe it's 1 to acknowledge. That goes back to the computer system and then they take over tracking all of that. I have a slide at the end to show a very specific workflow if that's something you'd want to see. But yes,
no, I believe you. I appreciate it. I believe you. That's a really strong differentiator. Thank you.
Yeah, this is Chip. I've been faced with this problem before. I think we all have in the military about trying to make sure you know where your people are. What about if people are not near their phone? And I say that knowing that, you know, if you're in a SCIF or you're in some areas of the embassy, I imagine you might have that problem regardless of what process you use, but this requires you to be next to your phone and have your phone, right? And the phone has to be on.
Yes, to be completely honest, that is exactly the problem. But what we're doing is under the assumption that you have your phone on you most times, this automates the process that would have happened anyway. So it's rather than getting the message super late because someone's doing manually, in the event that you do have your phone, you would get it a lot quicker. And, you know, for the majority of the time, that saves countless hours and saves a lot of lives.
Thank you.
Did that answer your question, Chip?
Yes, I'm sorry. I thought I said thank you. Yep, it did. Good.
Awesome. Any other questions? We have time for 1 or 2 more.
If there aren't any questions, am I allowed to kind of just show a couple extra appendix slides that I have that may answer questions that aren't already
Sure,
posed?
I'll give you like 60 seconds, Brian.
Okay.
Ryan, this sure beats the pagers they gave us back in 2001.
Yeah. Yeah, we're definitely trying to make this a lot more streamlined. I thought the 5,000 hours from the calculation that we were doing is very important. You know, that's 5,000 hours that we calculate out of Luke, which is about 7,000 people. Say you've got a base of 250 like Fort Bragg or something. This obviously takes a lot longer. So the current protocol is about 24 hours. It's currently being done in about 72. We can bring that down substantially. Our estimates are about 10 hours or less. That's a very conservative estimate, but either way, we're looking to get it done bring that time down as small as possible. These are just an example of that system overview that I was mentioning before. So it's sent out through GovCloud, which is the DoD's like secure cloud system run by Amazon. Goes to SMS. You get the information. It's run back to AWS, and they do calculations on who's not responded yet, who has. Maybe every 3 hours or whatever you set up in settings, you'll blast another message until that person responds, etc. Yes. And then that's an example of the market sizing that we're looking at. Okay, are there any other questions?
Great, thank you, Ryan. Great job.
Thanks, everyone.
Unfortunately, this is our halfway point, which means no trivia, but fortunately it means we get a break. So we're gonna take about a 10-minute break here. So feel free, go camera off, take a walk, stretch for a second, grab an extra cup of coffee, anything that you need to do. And we'll see you all back here at 2:22, we'll say.
Hey, Terry, the last snowstorm of the season is supposed to hit today if you want to come on up.
Oh, we're gonna rake in lots of money. Ian at one point was telling everyone, just so everyone's in on the inside joke, about his side gig of snow plowing, and we were doing the math and we're like, oh my God, this guy's making a killing doing this.
How's the elbow, Ian?
I have almost full extension, still a little bit, you can see right there, but it's like to the point where it's so tight that I think I'm gonna have to get some assistance working it out. So I talked to one of the black belts at jiu-jitsu. He said he has no problem helping me do this.
Eventually we'll have some time at the end to finish that one. Welcome back, welcome back. We are transitioning into the second half of our pitches here. Up next, we will have Team LV. So whenever you guys are ready, feel free to bring your presentation up and we'll get right into it.
You. Hello, I'm Sarah Myers, part of Team LV. LV provides performance vision for your lower legs. Soldiers' musculoskeletal injuries cost the Department of Defense more than 8 million duty days a year at an estimated cost of $19.2 billion. 45% of new recruits are injured in basic combat training, and musculoskeletal injuries far outpace any other reason for lost duty. LV Smart insoles can reduce injuries by providing detailed information about the forces exerted on the soldiers and how their movement is affected by terrain, loads they carry, and other obstacles in their navigation environment. Developed at MIT Lincoln Labs, LV is designed to take accurate measurements in a field setting. You can see the boot insole sensors and ankle package. It is designed to measure force and lower leg motion. LV has 2 patented technologies, a novel load cell and an efficient communication technique between sensors that is low energy cost, promoting long battery life. Other sensors can be integrated, such as a barometric sensor to detect whether the user is walking uphill, downhill, or on level ground. The insert contains LV load cells to measure force. Here is a closer look at the 2nd generation prototype under evaluation at MIT Lincoln Labs. The idea behind LV is that it can be inserted into the shoe or boot. LV monitors how movement changes throughout the day or mission. LV alerts at the critical point when an injury is likely to occur or fatigue starts to impact performance. And LV can be used alone or connected to a personal device. In pilot studies with soldiers, LV detected differences in mobility and agility in real time. The overall goal is to contribute to the longevity of soldiers by preventing injuries, starting from basic training. LV solves issues related to portability, connectivity, and durability when measuring gait in real-world settings. LV is an easy-to-use markerless kinematic and kinetic capability that can acquire lower leg biomechanics data all day long. The LV insert and ankle package can be integrated into a boot or the shoe at the manufacturer for an easy on-off solution. LV is the only solution that meets the needs of the DoD. MIT Lincoln Labs and the Marine Expeditionary Rifle Squad have upcoming field trials to test LV on 100 soldiers. Our next goal is to test LV during a field training exercise at the National Training Center, instrumenting up to a full battalion of soldiers. The next step would be to implement LV during basic training. If just 10% of new recruits would use LV, that would result in 15,000 units per year and an annual revenue of tens of millions of dollars. The cost of soldiers having to repeat basic training is upwards of $3.5 billion per year. At a goal cost of $1,000 per pair, LV would save the Army $50,000 in 132 lost duty days for each injury prevented. Other potential use cases would expand the market for LV, such as the Thor 3 program or other combat training centers that have high operational tempos that can increase injury risk. There are also applications in naval service members who walk on hard ship surfaces and Air Force technicians who handle and move heavy equipment. LV is pursuing new R&D funding to develop individual soldier and squad readiness metrics. We recently applied for funding through the Defense Health Agency to use the LV insert to measure impact loading conditions. Current development goals focus on increasing manufacturability to bring LV to market at a competitive price point. We have been approved by the National Institute on Aging to submit a proposal using LV to predict mild cognitive impairment in older adults. We are also pursuing funding through the Department of Homeland Security to use LV as an everyday wearable for personnel in the field. Our founding team includes Bobby Azuda, who has completed numerous DoD SBIRs and rapid product development efforts, and myself with expertise in biomechanics research. Thank you, and we look forward to your questions.
So this Chip, so this is a very crowded field, especially when you start thinking about special ops between rings and watches, and your sensor is down on the ankle and it looks to be resting right above the boot, and then it has to get connected into the inner sole. How much have you tested that connection for wear, if you will, with sweat and that stuff, or irritation on the service member? And is your roadmap bring that down and just have it inserted into the, your, whatever, the sole, inner sole?
Right. So we've been testing, we tested LV. Actually, the insole and the ankle package are already integrated together. And so the insole would replace the insole in the boot or shoe. And longer term, we could integrate the ankle package into a boot, but feedback from the soldiers that we worked with and their supervisors, they actually wanted it separate because of the frequency with which personnel change footwear. And so that's why we've gone this direction at this point. But we have been able to decrease the size of the ankle package significantly from the first generation prototype. And so we're hopeful that we can continue to make improvements. And then in terms of durability, that's actually one of the distinguishing features of our product versus some of the research grade pressure insoles and IMU combinations that are out there already.
Thank you.
Mm-hmm.
What's your target weight for this product?
In terms of device weight or for load capacity?
No, in terms of device weight.
The current insole just replaces your standard insole. The sensor package it consists of carrier metal foils that are add almost no weight at all. And the ankle package currently is about the size of an Apple Watch and the same weight. So you can imagine the total increase in, we'll say, the entire boot system is would only be a couple ounces for the soldier.
All right,
and most of that is in the battery. So our battery, we are targeting all day use, so 16 hours. So you could go with a smaller battery, which would decrease that ankle package size, cost of longevity throughout the day.
And I missed it. Does this give you real time on your phone? Is that the idea, or where does it?
Yeah.
Where does it? Okay.
So currently it's going with Bluetooth to a computer or phone or tablet, and it could be real time to a smartwatch. It just depends on the users and their goals and whether or not they can have personal devices or not. And then the data is also stored on board and can be downloaded at a later time.
Okay, thanks.
Mm-hmm.
Awesome. I think we have time for one more question if any of the judges have one final question for LV. Awesome. Okay, I think we're good. Thank you, Sarah. Thank you, Bobby. We will take it back to Terry's trivia for the next few minutes here.
All right, here we go. Hope everyone's minds are rested, not that you guys needed it. So we will start the clock. Any guesses? Let's see here, pulling up the chat. What does it say? Ferris wheel in London from Ian. Evan looks like he's really thinking about it. All right, final 5 seconds.
Ian, I challenge you to think of what Ferris wheel or what it is called. There we go. We got London Eye in the chat. Someone helped you out, Ian.
Yeah, nice teamwork. All right, good job, everyone. Let's see if you can figure out this next one.
This might be a stumper.
All right, good.
It's Amsterdam, I think.
Amsterdam.
Is that Largo? Is that
Largo? That was it. Yeah. I like this is like when you're
Mar-a-Lago.
in high school.
Mar-a-Lago, that's what it is. Yeah.
It's like when you're in high school and you have multiple choice tests, you didn't know what to go with. So they're like, just pick one randomly. It's better than nothing. People just throwing out places in the world. All right. Final seconds here. The Imperial Palace, Tokyo, Japan. Trying to
So Mar-a-Lago is pretty close to that.
Yeah, potato. All right. I think we'll have time for one more here, Jillian, or two more maybe. All right.
Let's do one more.
Sweet. All right.
Panama Canal.
We got Panama. We got New Orleans. What else we got? I see a lot of curious faces. Throw in some guesses. Hawaii from Evan. The Big Island. All right. Final call here in the last couple seconds. Chip is an unstoppable identifying geospatial identifying machine. Awesome. All right, Jillian, you tell me one more or we're done here.
Let's move on. We'll
yeah,
have, I think we'll have some extra time at the end if we need to bring it back up at the end.
Sounds good.
Awesome. Okay, our next presenting team is the Cutting Edge AI team. So Logan and Catherine, whenever you guys are ready, take it away.
All right, how's my audio and screen?
Great, we can hear you and see you.
Awesome, great. We are Cutting Edge AI, and we are designed to take any full motion video and make it indexable, searchable, and useful. The real problem set that we're accomplishing here is there is hundreds of thousands of hours of wasted video feed, either because it's being streamed into a watch floor where a human operator is inundated and has too many feeds to review, or it's being live streamed and there's no one with eyes on at the time, or what was being looked for in a specific mission set doesn't match the requirements a month down the road. So what Cutting Edge AI does is allows for autonomous detection of objects and then stores those indexed objects for further recall and analysis later. This is a huge problem set that video feed is not getting harvested and utilized in real time and illicit actors understand the gaps that we have in our watch floors and are exploiting it. The cutting edge AI dashboard not only detects imagery, but also does automated analytics on what was seen, how frequently it was found, and its pattern of life. So this allows human operators to quickly do what human analysts are good at, which is hunt and investigate, and computers do what they're good at, which is do autonomous object detection. Autonomous object detection can be applied to any class. We have over 1,000 different classes of objects we look for, and then we spin in the user's feedback from the dashboard to be able to identify new classes or new emerging items of interest. So it can go anywhere from just detecting people in a movie street all the way down to a model looking for a COVID mask or not. This is a quick use case of what an operator could do. So they very easily are able to see a heat map of the density of a type of object that was found across time, and then drill down into those instances and see a list of the objects that were found. So for a crime being committed or an illicit actor, you could say within a certain time range, show me all people that were identified, or all vehicles or bicycles or backpacks. The dashboard then allows you to drill down through the still imagery into a buffered video clip for context, and then can pull up the live feed autonomously. Our unsupervised learning can then go and create patterns of activity, which render in timelines of events and can show similar patterns of activity. So even if you have a perimeter security location where you don't have the same vehicle driving around doing surveillance, you'd be able to detect if there is a vehicle that shows up and has the same pattern of activity every Tuesday evening or every Thursday at 5 o'clock. So really what this does is allows our human operators to be proactive and get predictive insights on not only security, but the logistics of things going around within their facility and intelligence for ISR mission sets. This can be done on real-time live stream video or archived index video that can be uploaded and then made searchable. The way that we actually store the data results in a 98% reduction in file size. So instead of needing to write to a hard drive on a CCTV system where you're storing MP4 video files, we can store just the still imagery, the metadata, and a buffered video clip, depending on what's relevant within that feed. And then it reduces the amount of human effort that is required to scroll through and find specific events within those feeds. We have a proprietary edge hardware device that can sit on location and do the object detection on the edge. We can spin that into an on-premises server that does all of our unsupervised learning, or for our commercial customers or DoD customers that don't need a strictly on-premises solution, that can all be done in the cloud and then is accessible where we can crowdsource other video feeds and other data sets to provide better and better algorithms. Our system is a force multiplier because we have focused on not necessarily building the best classifier for any one type of object, but we've built the best video processing platform. We can hot swap in different AI models at any time, and we can retrain on information that's coming in. As part of our Hacking for Defense startup venture, we interviewed hundreds of end users, and one of the main things that we found from within DoD is that even if you have a great AI model that's good at detecting basketballs, once it's deployed and receives new information, it's already out of date. So our system is designed to be continually harvesting the information that's coming in through the video feeds. And we have a provisional patent on how to take those images, render 3D mockups, and use them for synthetic data sets for new model creation. This is just a roll-up of our differentiators. I'll pause there and leave it for questions on some of the aspects of our technology or use cases.
Who do you think your #1 competitor is?
Yeah, so on the AI model creation side, there's some really good competitors that are doing work for the JAIC or Project Maven. And we don't really intend to compete with them because they have very specific types of things they're looking for. For the broad platform applicability, probably our largest competitor are some commercial applications. There's one called Spot AI, which is designed to ingest all of your CCTV systems and then do this indexing and make it searchable. But they are just leveraging Amazon's recognition. They don't have any custom models and they don't have any way to dynamically retrain. So We do have some competitors in this space, but we haven't seen anyone that really has built an all-encompassing platform like we have.
Thank you.
Hey, this is Randy. My background's in digital forensics, and you may have answered this, but you did say this could be run against existing video, correct? So if I've got a lot of collected evidence, I could run this against it overnight or whatever. The next day come in, it's all indexed and just be able to search through it very quickly.
Yeah, that's exactly right. And we're pursuing a CRADA with the Air Force Research Lab. We're doing faster than real-time indexing. So we could essentially take 24 hours of video and run it 20 times faster and have it indexed in, a fraction of the time. This has been really useful for the sheriff's office that we have pilots with, for when they have to go collect private cameras, gas station traffic cameras. We can index all but make it searchable for them.
Yeah, that's what I was asking. Yeah, the law enforcement aspect of this, that be huge. Thank you.
Yeah, absolutely. Yeah.
Did you say that this is real time as well? So as it's going on, it could flag you if it saw something like somebody without a mask or just making something up?
Yeah, that's correct. Right now, our latency, even over Wi-Fi or not, the greatest connection, is about 3 seconds live video to the indexed dashboard that's web accessible. So this can be run with tripwires in real time, absolutely. And we can do it not only over CCTV systems, but any streaming video, including any open video feed you can find on the internet.
Thanks.
Awesome. Maybe time for one more question from the judges. If not, they're just being super polite and want more time for trivia, right?
Yeah, I guess I'll mention on some of the supply chain things. We are doing AI, which requires hardware. We're in the NVIDIA Inception program, so shout out to Opto Relay. Definitely take them up on that offer. It gives us huge discounts on the hardware and gets us to the top of the supply chain. So all those GPUs that are in high demand, we have most of them. So if anyone's angry because their gaming computers on back order, it's probably our fault.
Awesome. Thank you, Cutting Edge team. Judges, over to you to fill out your scorecard, and Terry, over to you to entertain us.
Happy to do what I can. Let's see here. All right. Let's see what you guys got. Pulling up the chat here. Rome, okay. Some talk about Bitcoin mining, also interesting and fun in the chat. Everyone see the executive order that came out today? Paris, another good one. Lisa, you're doing much better. You're improving. Venice, okay. Everyone's head is in the right space. All right, last few seconds. Florence, Italy. So everyone was really close. People were in the right mindset. All right.
Grand Canyon.
Lisa got that one too. She guessed Grand Canyon.
Gobi Desert.
I got to know I'm right if I match Chip.
Yeah. All right.
Actually, my oldest child lives there. That's how I got it.
Oh, they live near the Grand Canyon?
Yep, they're about 40 minutes from the North Rim.
Wow, that's awesome. Ian, I do appreciate the creativity with Gobi Desert, though. All right.
I got nothing.
No worries.
Jerusalem.
Temple Mount in Jerusalem specifically.
Oh.
It might actually be the Wailing Wall there in the shadow on the left, or right down the center.
Yep.
Chip, Ian
That's right.
saw your Jerusalem and raised you.
He's right. Yeah, he's got it.
He's got it. All right. Well, this is a speed round. We'll do one more, right, Jillian? Or
yes.
You tell me. Awesome.
Go for it.
Okay. Let's see if we can end strong here.
Is that the Imperial Palace in China?
That's
looks like
one.
Yeah, looks like Carlin agrees with you. Give it a couple more seconds. That's right. That was impressive. I did not think people were going to get this one.
Crew. I'm impressed.
Yeah, I did not. Some of these I'm like, okay, they'll get. Like Florence, I really thought you guys would get. Surprisingly, no one got it. Forbidden City, I was like, no one's going to get this. So,
well, if tech is not in some people's future, guessing things on Google Earth definitely is what I've learned today. Awesome. Cool. Okay, we are moving on to our second to last team, if you guys can believe it. The day has gone by so quickly. But up next, we have our team Skyline Nav AI. So whenever you guys are ready, feel free to take it away.
Great. Thank you, Jillian. Can you all see my screen, by the way?
Yes, Conor, we can see it.
All right. Good afternoon, everyone. I'm Kanwar Singh, representing Skyline Nav AI. Imagine you're a soldier conducting patrol in Baghdad or any other city, and suddenly you end up losing GPS connectivity. Well, there's actually very limited options. As an Army officer, I'm trained to rely on my map and compass. Now, the challenge with map and compass, as most people on this call likely know, is you can make computation errors, you may have outdated maps, you may necessarily not have the most reliable way to navigate. Over the past 2 years since we started this company, we've done over 200 customer interviews. And so we have a quote from a former SOCOM officer who said, I quote, "We lean too heavily on GPS and don't have a good backup system to augment it." A few years ago, there was this video circulating online, and no one could determine where this video was taken. It was a potential genocide being carried out by some soldiers in some foreign military's uniform. Now, BBC journalists went out and started identifying this video's location, and they used Skyline to identify natural and man-made features. It took them months to geolocate that video. If they had a technology like ours, it might have happened within a few seconds or perhaps minutes. Now, recently with Ukraine, we have actually identified a situation where GPS was being blocked by Russia before they carried out their combat operations. And that was a signal that, hey, there could be an interference happening. It's also very easy to buy these GPS jammers, blockers online, and that's a huge national security threat. There's also the issue with solar storm and cybersecurity, right? Just our potential adversaries, near-peer threats can take out our GPS satellite, and then our solar storms can also knock them out, which would actually bring our economy and our national security and put it in a very grave situation. The federal government has been investigating it, but more needs to be done with some additional technologies, and we believe ours can be one of the solutions out there. Before I get into the technology, I want to talk about our team. It's myself, Dr. Raj Surati, Dr. Chris Burrell, who was the lead inventor of this technology at Army Research Lab. We've actually licensed this technology to our company, and then we also have two advisors, Rob Nicholson and Tony Marash. We've gone through the FedTech NSIN program. We've also are going through this Vector program. We have partnerships, collaborations with MIT and Draper Labs. Pleased to share, a few weeks ago, we got notified. We've gotten our phase 2 STTR from AFWorks, which is going to really accelerate the commercialization of our technology. We've also gone through National Science Foundation I-Core program, and we are in the process of applying for some additional silver funding from them for our commercial use cases. So what's our team's focus? We are focused on position and navigation in a GPS degraded denied environment, identifying location of an image or video, and improving accuracy of GPS by eliminating bound signal. I'm going to hand it over to Raj, who'll tell us more about the technology. Raj?
Hi. Our initial solution uses the unique skyline signature to determine a location when the skyline is discernible. The proprietary algorithm uses points from the skyline you can get from a 360-degree image like that shown here, matched against those which would be computed using a digital surface model of the local area. Here, for example, is an urban area where GPS does not work well because of, Conor, can you go back? Yep. Here, for example, is an urban area where GPS does not work well because of tall buildings. With Skyline, you can get a result that is much more accurate. And the algorithm works in other areas, such as the suburban, country, and other kinds of areas shown here. The patent pending method is significantly faster than other known visual methods and has been heavily virtually tested in 4 cities on thousands of locations: Baltimore, Boston, NYC, and Washington, DC. Back to Conwar.
Thanks, Raj. Let's talk about the military and commercial applications. This technology can be used as mounted, dismounted, and can also be used with law enforcement, autonomous vehicle, drone, among other technology. On the intelligence side, our technology can be used on precision-guided munition, reverse image search for search and rescue, as well as navigation and positioning on handheld devices. Let's compare our technology compared to others. Our technology can complement GPS where GPS doesn't work. There are some alternatives, but as shown on the slide, they're not as effective and as precise as our technology. We are using our technology in its current form on an iOS app and making it into an ATAC primarily for the Air Force. We would love to get this award so we can use that $25,000 to build additional use cases for intelligence and commercial sectors. This concludes our presentation. I'm happy to answer any questions you may have.
All right,
So
go ahead.
Is Chip, so you can take a picture of anywhere off a standard iPhone or whatever, upload it into your system, and it visually determines where you are with no rough ROM of where you are. You could be, it doesn't matter whether you're in Canada or Boston or Dallas, it will be able to figure that out.
That is correct, Chip. As long as we have your approximate location, right? So you could tell us that, hey, you're located in the state of Massachusetts, and then we can run your imagery that you've taken from your cell phone device and give you your precise location. Now, if we had all the compute power in the world, in other words, if it was not being done on an edge device like a mobile device, then you don't even need to give us your approximate location.
Okay, thank you.
Absolutely.
So yeah, that's what I was going to ask is so your processing's all done in the cloud. What would happen if you didn't have access to the processing of the cloud?
So yeah, so there's two separate use cases here, Giza. We actually do not require processing of the image on the cloud. We can download the digital surface model datasets directly on the edge device. And so without any cellular, mobile, GPS connectivity, we can still give you your exact location. So the use case here is, let's say you're a soldier leaving a TAC or a TOC, and then you'd be able to download those surface models before you step off. And then let's say you're in a position where you're like, yeah, I have no GPS connectivity. You can then use our technology, take a quick 360 image, and it'll do the geolocation directly on your device itself.
Well, I think you're right with a lot of cases here because you need a distributed approach to deny GPS. So you need the signal. If you don't have the signal, you need to roll to inertial. If you don't have inertial, you may have to roll to a visual. You may have, I mean, you can do it off of gravity. You can do it off of isogonic lines. Whole lot of ways you can do this. This is one of the this would be a pretty, I think, a pretty important piece of the puzzle. And just what happens if you're in like a desert?
That's what I was just going to ask.
Yeah.
That is one area where our technology does not work, right? So if it's like a flat surface with no natural or man-made features, then we would not be able to navigate, right, in that situation. Same thing if you're in the middle of the ocean, this technology would not work. So it does need skyline imagery. So as you can see on the slide, right, I mean, as long as there is some unique man-made or natural feature set, we can actually identify those points and give you your exact location. Same thing also, let's say you're flying a drone, right? If you end up blocking the GPS, as we have seen Russians do to the Ukrainian military, I mean, they're in a tough spot, right? And so, if you have a technology like ours, we'd still be able to navigate and position you using the camera sensors, either on a drone or vehicle or truck, etc.
We have time for one more question. If any of the judges have final thoughts. Great. Okay. Thank you, Skyline team, so much. I'm pretty sure this is the last trivia that we'll do for the day. So the stakes are high. Everyone get your brains ready. And Terry, over to you.
I appreciated whoever's comment it was if we could use Skyline to help figure out these geotag locations. But we cannot, and we just have to rely on our good old-fashioned brain. So for our last round, any guesses on this one?
Island.
Where was it? Where was it?
Thailand.
Thailand? Okay, that's a guess.
Got a guess for Stockholm in the chat.
Stockholm,
That's
all right.
That's a good one.
All right.
Chip, are we stumping you with this one?
I think you got me on this one. I think it's in Northern Europe.
Finally.
I can't.
I don't care what else happens today. This was a win for me.
I was just going to say Stockholm because I was just there, and I was like, when I bopped over, I went, I think that is Stockholm.
Great job, Anna.
Yeah, good job, Anna. All right. What do you guys think about this one?
It's one of the temples in South America. I can't place which country.
Okay.
I'm lost. I'm out.
Oh. All right, good. Finally, we're getting somewhere here. Really tricking you guys. Give it a couple more seconds.
Took us 8 teams, but we finally got to the tough ones.
Yeah. All right, seeing some interesting guesses here. Nice job, Chris. Nice job, Kyle. All right, let's do one more, and then I think we'll end it here.
I see a golf course.
That would be an awesome golf course. Suez Canal, okay. Victoria Falls, all right. Ready? All right, last 5 seconds, people.
Hoover Dam, no clue.
Hoover Dam, all right. Good job on Victoria Falls, Kyle.
Kyle's been like the underdog all day with this game.
Yeah, seriously. Well, thank you guys so much for having some fun with us today and playing this game with me.
Yeah, thank you, Terry, for providing the entertainment. And with that, I'll turn it over to our last team, Anna Melker from Monolithium. So Anna, whenever you're ready, take it away.
All right, are you able to see my screen?
Yes, we can see it.
Okay, and you can hear me, I guess. Okay, yep. Hi everybody, my name is Anna Melker. Some background about myself. I have a PhD in materials chemistry from the University of California, Santa Barbara, where I also studied technology management and entrepreneurship. And after graduating, I started a company in digital health, which I ran for 2.5 years. And more recently, I've been a technology and national security fellow at the Department of Defense. And I'm here today to talk to you about monolithium, which is the battery of the future. So to give you a little bit of context, lithium ion battery technology was first invented in the late 1970s. And some postdocs at the University of Texas were working on the technology, doing prototypes of it. It was actually first commercialized by a Japanese company, Sony, in the early 90s. And not a day goes by where energy is not in the news and renewable energy is not in the news. So the DoD has officially said that climate change is a national security risk. Remember the floods in New York from last summer. And more recently, the geopolitical tensions globally have really pushed the effort to go over to more renewable energy and electric vehicles. However, there are some fundamental flaws with lithium ion battery technology. And that's because batteries can be kind of seen like a bomb. There are a lot of energy contained in something that's quite explosive and contains very flammable liquids and some nasty chemicals. Lithium ion batteries also contain cobalt, which is an expensive starting material and is a national security risk. So you can see on the left side here, battery cathode materials, and the blue line is cobalt. It's far and away the most expensive component of batteries. And then on the right, there's a comparison of where different battery materials are sourced from. Most cobalt comes from the Congo, and it's processed by our greatest adversary. Another reason why cobalt is bad is that it's mostly mined by children. And just to recap, some of the problems with lithium-ion batteries today is there's a long recharge time. You can see that with your neighbor, yourself, charging an electric vehicle. They contain toxic liquids and can kill you if you get trapped in your car when the battery explodes. In contrast, monolithium's proprietary chemical composition is cobalt-free, which makes it cheaper to produce and has a safer supply chain, no child labor. It's also fundamentally safe because it's solid state. So it's non-toxic and non-flammable, no liquid at all. It also has a fast recharge time in under 10 minutes and a high voltage. There's also several swap advantages. You can make it conformal. There's a weight reduction because there's no separators and no liquids and no battery management system. And there's a higher voltage. There's also the advantage of this technology being useful in both the commercial and the defense sector. So some of the early applications we've identified are in unmanned aerial vehicles and tactical microgrids, and for the commercial sector in power tools, and in any sort of medical device where you'd want to have something safe against the skin. There's also very specific environments for the DoD where a safe battery is just a great advantage. One of them being in submarines, another for simplifying aircraft cargo shipping. So you don't need to have some of the logistics around the way that lithium-ion batteries are shipped today. And then it's also safer for soldiers to carry because you're not worried about this thing exploding on your skin if it gets too hot or it gets pierced. We conducted several interviews with industry customers, and they reiterated some of the positive attributes of the monolithium battery: low cost, something that's solid state, fast charge, and high temperature. There's a great expanding market size for batteries. And just to recap the major differences between monolithium and lithium-ion batteries, it supports national security, low cost, high power, fast charge, and high temperature operation, so much higher than lithium-ion, and then comparable energy density and energy capacity.
All right,
right now,
we're at the 5-minute mark, so we'll transition into our Q&A, but definitely cover some of your final items during the Q&A if time allows.
Sure.
Judges, over to you.
To ask my manufacturing question again. So how is this manufacturable, scalable, et cetera?
So this is, you're able to make this the same way that lithium-ion batteries are currently made. So in a drop cast, tape cast method, and uses the same equipment that we currently use for lithium-ion batteries.
I apologize if this is a dumb question, but is the real issue here that it is safer than a lithium-ion battery, or that it produces more power, density, less heat? When you boil it all down, what's the discriminator here? Is it that it's safer or that it provides more power?
That it's safer. So it's a solid state battery.
Okay.
Any other questions from the judges?
Yep, sorry, I was on mute.
You're good, Lisa.
So it's safer. It does the same thing or better. Is it way more expensive? 100 times, 10 times, 1,000 times?
Just a rough calculation is 3 times less expensive than lithium ion because it doesn't have any cobalt, which is the major cost in batteries.
When will it be ready?
So right now it's quite early TRL level, around 3 and 4, and we want to get it up to a 6 in the next couple of years. So currently working on SBIR grants and having the Army Research Lab continue development with the CRADA.
Have you heard of Catherine Marsh at IARPA?
Yes.
Okay, if she would be one that would be worth talking to, I think.
Okay, thank you.
Yep.
So maybe time for one more, if there's any last lingering thoughts, comments. Great. Okay. Thank you, Anna, then. Great presentation. And thank you for finishing us off strong here. And thank you to all the 9 teams for your time today and your presentations. That does conclude our final pitch. So judges, please take a moment to fill out your scorecard for Team Monolithium, and then we'll place you in a breakout room for final deliberation. So we'll just wait here momentarily before opening up that breakout room. Right, so we are going to transition into kind of the final deliberation portion. Judges, you will be sent into a breakout room shortly, and you'll have about 10 to 15 minutes to deliberate and have the Herculean task of deciding a winner for today's pitch competition. So whenever you're ready, Emily, feel free to open the breakout room, and everyone else will hang out here in the main room for a little bit, and we'll have some specialty awards. I think we're just waiting for one judge to move over. Randy, if you're there and if you can hear us, we're just trying to send you out to the breakout room really quickly here. Sorry, everyone, bear with us here for just one moment. Oh, Evan, I can't hear you if you're speaking. Okay, I think we are good. I am going to go ahead and start our specialty awards while we wait for the judges to make the final decision. We have 3 special non-monetary awards that we will give out today. The first is our Decode Dunk Hard Award, and we use the term dunk hard at Decode to signify someone who always goes above and beyond and always gives 110% to everything that they do, and really sees an effort from beginning to end through with true dedication and commitment all the way. So today we are awarding the Decode Dunk Hard Award to, drum roll everyone, Team LB gets the Dunk Hard Award. So Sarah, Bobby, you guys have truly done just that. You've done a great job with the curriculum. You've always attended office hours and have just shown a lot of commitment to the Vector program. So we're super proud of you and honored to award you with the Dunk Hard Award.
Thank you so much.
Thank you.
Welcome. Awesome. Okay, next we have Most Improved, and it goes a bit without saying, but the winner of our Most Improved Award today is someone that has shown a lot of growth, both business-wise and personally and professionally throughout the program. So we are proud, the Decode team is proud to honor Ryan from Apagos with Most Improved.
Thank you.
Welcome, congrats. And then lastly, I do love the idea of doing a best logo for next time. Unfortunately, we did not think of that one for this cohort, but it's in the brain, Logan, for next time. We are going to do an audience's choice poll. So in a moment, Emily will launch the poll, and this is for both our teams and our other audience members today, if they'd like to put in a vote. Obviously, we're trusting that the teams will not vote for themselves, but this is just voting on your favorite pitch of the day, who you thought had the best presentation today, and that will be via Zoom poll that will launch momentarily. So feel free to take a moment, get your votes in. All right, we have about half of the votes in, so another moment here. It is a very close race, so make sure you get your voice heard. We'll give it another minute here. All right, like 30 more seconds. Final countdown. There's still about 10 to 12 people that have the opportunity to vote if you would like to do so. We do have a tie right now too. So if one more person wants to vote, be the tiebreaker, the suspense. All right. It's looking like that's all we have. Oh, we got one last vote. Okay, tie has been broke. No, there's still a tie. That's all right. We'll close the poll. We'll award to audience's choice. Emily, feel free to end the poll and we can share the results. So it looks like, can everybody see it now? It looks like there's a tie between Kupros and LV for audience's choice today. I love all the votes though, a nice range of teams up here. Awesome. Okay, so all the teams who are awarded specialty awards, you'll get a message from me with your little certificate after pitch day here. Congrats again, and thank you for all of your presentations today. The judges are still deliberating, so we'll just take a brief break here. So feel free to go camera off and chill before we have our big final award ceremony for the $25,000 contract. Back, judges. Welcome back, judges. We almost perfectly timed that by playing final countdown. So I'm equally as impressed with the fact that you were able to select a winner and the fact that we perfectly timed the DJ. So Andrew, I will turn it over to you for our final award ceremony.
Okay, thank you, Jillian. Before that, actually, we discussed with Terry and the judges, we'd like a few of the judges would like to give some general feedback about all of the presentations overall. And then after that, I'll announce the winner. So
all right, I was muted, sorry. This is Lisa. I got voted to talk first because I talked too much. But just wanted to tell all of you, thank you so much for really bringing a high quality product for each and every one of you. These were very unique. I thought it was interesting that you all got to hear each other, and I think that was great. The singular piece of feedback that I would give to all of you when you're doing this type of a 5-minute pitch, really make your point about your secret sauce, what makes you unique. We should all be able to know what that is and be able to articulate that, because that's what sticks in our mind when we give an assessment. Over.
Okay, I'll just chime in on top of that. I thought that's a great comment, Lisa. I would add that there was some of the presentations took a lot of time to set the stage. You have to be comfortable that with one slide or a couple words that the audience is already kind of aware of what you do. So set that stage really early and get right to that point of what Lisa was talking about. I felt a lot of the briefs lacked a little bit of detail on the tech and making us feel comfortable with, okay, they really it's not vaporware, it's really there. When you tell us what TRL level you're at, all that is helpful for us to understand how to engage and whether or not we should just put you on the watch list and come back to you 6 months later. No, but one thing I would say is that I did this about 8 months ago, and the briefs are getting so much better. So hats off to Decode for getting you guys where you need to go, and NSIN as well.
All right, and that, I believe, concludes judging feedback. I'll say to all the teams, really good job. Behind the scenes, you weren't able to see, but it was a hard fought debate to pick the winner. I know the top 4 teams score wise were very, very close, and you'll have an opportunity to debrief with us, NSIN, following this. Besides that, almost all the teams, there's somebody that somebody wants you to talk to. So this is not the end of your dual use journey by any means. And you did a really good job of garnering interest from your presentations today. With that being said, I can't build up the suspense anymore. There's no third place runner up here. There's only one winner who gets the 25K today. So I won't delay it any longer. The winning team is Neupro. Neupro, congratulations. You have won the first Vector Showcase of 2022. I'll be in touch shortly. Oh, and yeah, for the you're on screen here, which is awesome. For our news story, do you want to say any words about winning this event and your experience so far?
Well, I just wanted to cite the level of support we got from NSIN. You guys were great to work with. You had great materials. We've been through more than one type of these programs, and I think you guys really, really hit it on the head in terms of making connections within the DoD and giving teams guidance. And you guys were grinders, man. You made us work hard with these pitches throughout the entire program. So just we're very ecstatic to be here. We're glad it worked out, and thank you guys so much for the opportunity.
All right. Thank you, Matt, Jillian and team, and everybody who attended today. Thank you for coming. Thank you for seeing these pitches. We were recording, so there'll be an opportunity to see these teams pitch again at your own leisure and follow up if you thought of any connections. If not, like I said before, reach out to the teams directly, reach out to me on LinkedIn. We want to build these connections. We want to help all of these teams. So let's make it happen as a team. Everybody, thank you. Jillian, if you don't have any final words, congratulations again to Neupro. And I'll see you all later.
Yeah, all I say is I know I speak on behalf of the entire Decode team when I say it's truly been a pleasure and an honor working with you all. And this, again, is not the end of our engagement. So we look forward to keeping in touch and seeing all of your future successes. And thank you everyone for being here. So take care, good luck, and we'll see you all around. Thanks, everyone.
Ciao. See you later.
Thank you, Chip.
Yep. Bye. Say hello to Rebecca. Give her a bunch of crap for me.
Will do. Absolutely.
Right.
Gladly.
And same
Absolutely.
with Brian. Same with Brian. I was going to say Rebecca. Brian. God bless. He was with us in the quick. Then he went.
Brian Gorell.
Gorell. Tell
Yeah.
Brian. Yeah. Tell him he's a dead man. He hasn't checked in with me lately.
Okay.
Will do,
tell him.
Chip.
All right. See ya.
Thank you. Take care.
Bye.
I think everyone's gone. Can we stop recording?
Matt's still here from Neupro.